So my name's Andrew Mulholland. I go to Dalriada School in Ballymena. Anyone here from Dalriada?
Okay. A long time ago.
We're doing great. Okay, and I'm here to talk on physical computing. Does anyone here know what physical computing is? Okay. Well, I guess that's what you're here for. A wee bit about me. So I'm 17, I'm in upper sixth. I'm currently doing my A-levels. I'm doing maths, computing, and moving image arts. I'm Northern Ireland's youngest STEM ambassador. And I also teach robotics and computing related things for about 2 to 3 hours a week on average. Now, what is physical computing? Well, Wikipedia defines it as building interactive physical systems by the use of software and hardware that can sense and respond to the analog world, which I'm sure no one has any idea what that is. So I made my own one. It's in other words computers controlling parts of the physical world. For example, motors, you've got LEDs, you've got buttons, we lights, stuff like that. Fun stuff. Now to do that, you've got a couple of options. If you wanted to go into a classroom, you wanted to teach physical computing. Time for my box. You've got a couple of options. The first one is this thing. Lego Mindstorm. Anyone here heard of Lego Mindstorm? Okay, we've got two. Right, we're doing great. Lego Mindstorms, they're a pretty awesome robotics kit from Lego. They've been around for 15 years-ish. And there's been 3 different versions of them. But they're the most popular robotics platform ever sold. These things are awesome. But there's a slight issue with them. That point there at the bottom. They're a wee bit on the pricey side, £350. And I know, with the economic crisis and all that, not everyone has deep enough pockets to, get one of these things. Now, so you're thinking, oh no, can't bring physical computing into my class. Oh well, I'll give up. No. This thing here, I'm sure, anyone here not heard of the Raspberry Pi? Okay, right, we're doing great. Oh, that's my Raspberry Pi. Okay, whoops, that's my Raspberry Pi next door. Raspberry Pi, yeah, tiny credit card sized computer. Costs $35, about 28 pounds. These things are crazy awesome. You've got a computer that is a credit card size that you can plug into a normal TV, a normal screen, whatever, plug your keyboard, your mouse in, and you've got a fully blown working computer. You can go on the internet, you can open your photos, you can make PowerPoints, you can do whatever. So $35, it runs Linux. Immediately people feel, oh, scary Linux, that means lots of typing. Nope, you can click and drag, it's just like a normal computer. And you can run Scratch, you can run Python, you can do robotics, and you can actually also do Minecraft. Now, I've heard a couple of schools have started piloting Minecraft. You can write programs in Python, a simple programming language that can interact with this Minecraft world, which we have found kids just love because they love Minecraft, but they want to make their own mods. And so they love this thing. Now, the other thing then, though, the bit that I enjoy most about it, is on the Raspberry Pi, you've got these little things here, GPIO pins, general purpose input-output pins. They're, in other words, little pins that can output an on or an off signal. Sounds pretty boring. But if you combine that with an LED, maybe a wee resistor too in a breadboard, you can get a little flashing light. The kids could program in something like Scratch. Anyone here, or who here has used Scratch before? Yep, the kids already know how to use Scratch. They can go and just use all that stuff they've already learned and develop programs that can say turn on LEDs, turn on motors, and can get inputs from buttons and sensors and add-on boards and whatever. But we've taken this a step further. As I said, I teach robotics. So I founded my school's robotics club 4 years ago maybe. And most recently, this term, we started our own Coder Dojo. And so we came across the issue that this thing here was a little bit expensive. And when we announced our robotics club, we might have maybe sort of had 30, 40, 50 kids turn up on the first day and said, can I play with the robot? Slight issue being that we only had 2 of these things. So I'm sure you can all do the maths, it doesn't work out very well. So we've been developing and working on this thing here, a shrimpy, which we developed from the ground up. And ignore the wires, they'll all be replaced with a nice little circuit board that slots on top. And this thing is completely based around the Raspberry Pi. So we've got a nice big Raspberry Pi in the middle there. And, it was developed by us. It's based around the Raspberry Pi. It costs £85 for a robot. Now you can get it a little bit cheaper, if you don't want some of the sensors. But most schools we've talked to anyway, won all the sensors, and they're happy to pay £85 because they used to have to pay for that thing, which is crazy expensive. It's laser cut in our own school. I took like 3 minutes to make. And we're looking to possibly actually release this commercially this December. So if you're interested in, you want robots in your school, come talk to me at the end while I'm mailing this. But robotics in schools, there's a few misconceptions. I've talked with a lot of teachers when working on this project, and we've got a few misconceptions. First off, I need to be a computer expert to teach this robot, or to teach robotics in general. That's a bit of a lie. See this thing here? Anyone see any lines of code, in this? No? It's because there isn't any. This is how you program one of those robots. It's drag and drop pieces of code. That's it. We've also got you can program these robots, our shrimpies, in Scratch. So stuff kids already know. Kids can pick that up. You give them 10 minutes. Just leave them. And they'll figure it out. It's icons. You can kind of guess on motor of his gear. Too expensive. That's the other big one. I've already talked a wee bit about that. You can get a robot for £85. Not that bad. Now, the average school, we talked to schools and they said, right, we'd be willing to put in a bit of money. And we asked them, how much? And the roundabout figure that they were willing to put in to start their own robotics club was they were willing to put in about £700, which sounds like a lot, but they were willing to do it. So what can you get for £700? You get 8 of these robots. 8 robots. Put in your classroom. Now that works out by 32 students. Now, of course, you can use these over and over again. The students actually start off with building them. So they start off with a flat pack kit, we build it up. So there's a bit of design technology in there. I'm going over right, very quickly. It's not educational, it's just playing. Nope. Because we all know kids learn through playing. They learn that when they grew up through playing, having fun. And so this is why we like this, because kids love this, because it's fun. And why would they come back if it wasn't fun? And robotics is meant to spark innovation and creativity. And I'm going to run through this bit really, really quickly. It's all a waste of time. No, it's not. From our robotics club, we've gone ahead and we've won 3 big, massive UK competitions. Oh, look, there's me. All through robotics, because it encourages creativity and encourages innovation. So, if you're curious about any of this, come grab me at the end, and I will put you on a mailing list and mail you do some things. And yeah, that's to conclude. Robots are awesome and they encourage things. And there's me.